In this series of videos, we're going to look at calculating the arc length. To do that, first of all, we're just going to look at circles generally. If we recall that to find the circumference of a circle, we have to do pi times the diameter. And the diameter is the line that goes from circumference through the centre, through to the other side of the circumference. And just a reminder, the circumference is the outside edge. So for example, here to calculate the circumference, we would do C equals pi d. So C equals pi times 17.3. C equals 54.349 blah blah blah, and to one decimal place it'll be 54.3 centimetres. So the full distance around the outside here is 54.3 centimetres, but what we are going to look at is we're going to look at how to calculate the length of just a section of the circumference. We're going to look at how to calculate the section of an arc. So say for example, if we just had this area here, how would we calculate this arc length? Okay, the arc would be a part of the circumference. So essentially what we're going to do is we want to calculate a proportion of the circumference based on the information that it gives us in the question. If I gave you a semicircle and I asked you to calculate the circumference, I would hope that you would automatically just calculate the circumference and then just half your answer. And it's that sort of thinking we're going to apply to calculating the arc length, because half of your answer actually has like a logical reason to why you do that in relation to the angles that we will be using. So to calculate the arc length, so arc length has got to do with the circumference. So to calculate the arc length, we do pi d, which is just your regular circumference. We do pi d, and then we multiply that by our given angle over 360. For example, if we had a semicircle, we automatically should know that this angle in here is 180 degrees because it's a straight line. So if we were to calculate the circumference of this semicircle, we would do pi d and then we'd times it by a half, because we just know that we'd do half of the half of the circumference because it's half of a circle. But if we were to actually apply this formula here, we would have the formula pi d, whatever the diameter would be, and we would times that by our given angle 180 over 360. And I hope that we can spot that this can simplify to this. And so this formula is just intuitive to what you would actually use in real life, just some basic questions. If it was a quarter circle, you would quarter your answer. But if it was a quarter circle, this angle in here would be 90, so it would be 90 out of 360. Okay, so that's us now spoke about the formula. We're just going to have a look at it in practice. Okay, here let's imagine the question is asking me to calculate the length of this arc length here. So I want to figure out how big this part is here. I am given some information in the question. I'm giving that this value is 8 centimetres, and I'm given that the angle is 91 degrees. First step to do is you write down your formula. So your arc length, I'm just going to put arc L just for space. So it's pi times the diameter times your given angle over 360. Because this last part almost signifies the proportion of the circle, the proportion of the circumference that you will be working with. So we now just need to fill in the information that we've been given from the question. So the arc length equals pi d times x over 360. So pi is just a number, and I need to multiply that by the diameter. If I have a look here, I've got this line from the circumference to the centre. The line that joins the circumference to the centre is called the radius. It's half the way. The diameter, we need to go the full way across. The diameter goes from one side through the centre to the other. So the diameter, we need to remember, is double the radius. So if the radius is 8, the diameter would be 16 centimetres. So the diameter is double the length of the radius. So we're going to put the diameter here into our equation. So it's pi times 18 times by our given value, it's going to be x. So our given value x here is 91 degrees, and we're dividing that by 360. In your calculator, just multiply the things along the top, so pi times 16 times 91, then just divide that by 360. You get 12.705 blah blah blah. And if we're to do that to one decimal place, that will be 12.7 centimetres to one decimal place. So essentially all we're doing is we're just plugging these values into the formula. You just need to remember this formula. This formula is not given in an exam. It's not given in an exam. Okay, so just to recap, to find the arc length, the length of like a section of the circumference, you do your regular circumference, pi d, and then you just multiply that by your given angle out of 360, because that signifies the proportion that you're working with. Okay, let's have a look at this question a little bit differently. Let's imagine that we've been asked to calculate this arc length here again. This is usually called the minor arc, because the other corresponding arc, this arc here, would be the major arc. Okay, because it's bigger. So let's imagine we're asked to calculate the length of this arc here, and we are given the angle 116 degrees. We're given this angle in here. So let's first have a look at our formula. So we've got arc length equals pi d times x over 360 degrees. So in order to do this question, I need to know what the diameter is. And let's imagine the question doesn't give me the diameter. Let's imagine that the question just tells me that the circumference, let's imagine the question tells me the circumference is 62.3 centimetres. Let's imagine that it tells me that the circumference is 62.3 centimetres. So I'm not told what the diameter is. What you need to do is, I'd hope you'll be able to spot the relationship between the circumference and pi d. Remember, to calculate the circumference, you'll just do pi times the diameter. So the circumference is this numerical value here. But from the question, we are already told what this numerical value is. This pi d is the circumference. The question tells me the circumference is 62.3. So I can just substitute 62.3 into my expression here. So I'm going to do 62.3 times my angle is 116 degrees over 360 degrees. I'm just going to move this up a wee bit just so I can fill in my working. I'm going to do that in my calculator. 62.3 times 116 divided by 360 will give me 20.07 ... and if I round that to one decimal place, it'll be 20.1 centimetres. So this distance from here to here is 20.1 centimetres. Does that make sense? It tells me the circumference is 62.3, so this full distance all the way around is 62.3. This angle here is 116. 116 is actually quite close to 120, and 120 would have been a third of the circle. So we're expecting our arc length to be just less than a third of this. So a third of this would be 20 something. So we seem to be on track here. So if the question says that the circumference is this, calculate the arc length, that means you can substitute the circumference into this step here, because to calculate the circumference you just do pi times the diameter. In this final example, we're just going to look at it slightly differently. So far we've been looking at calculating the arc length. So far we've been looking at calculating this value in here. But I'm going to change this slightly. I am going to tell you that this arc length, this little section here, is 23.2 centimetres. I'm going to tell you that. And what I want you to calculate is I want you to calculate what the diameter is. So we are going to try and calculate the diameter. So this is like a question we've not really seen before. We're given an angle in the middle. We're told that our arc length is this. So it's not really clear how we're going to solve this. See if you're ever unsure of what to do with a question. If you're ever unsure of what to do with a question and it's regarding the arc length, what you should do is just write down your arc length formula and see like where it takes you. So I'm going to write down my arc length formula. So the arc length, arc L, equals pi d times x over 360 degrees. 360 degrees. So, I want to find out what this value is here. I want to find out what the diameter is. Let's see if I've got enough information to fill in some, values for the other variables. The question tells me that the arc length is 23.2. It tells me that the arc length is that. So see where I've got the arc length here. I know that the answer to this is 23.2. The arc length is 23.2. So that equals pi times the diameter. Remember, it's the diameter we're looking to calculate. And our angle is 71 degrees. It's not done to scale in the picture, but 71 degrees over 360 degrees. What I want to do is I want to make D, this one here, I want to make D the subject of the formula. I want it to be a D equals equation, because that will allow me to calculate the diameter. What I'm going to do is, first I am just going to bring my working up here just for space. First thing I'm going to do is I'm just going to rewrite my equation round the other way, times 71 over 360, and that equals 23.2. Okay, I can do that because they're equal. I can just swap the order around. I want to find out what the diameter is. So, if I first, there's different steps you can go about to do this, but if we're to think about solving equations and we had like a number at the bottom of a fraction, how we would get rid of that number at the bottom is we would multiply both sides by 360. So multiplying this side by 360 would get rid of this 360, and we're going to multiply this side by 360 here, struggling to fit it in. So on the left I'm going to have pi d times 71, and that is equal to 23.2 times 360. So that's 8,352. On the left hand side of my equation I've got pi d times 71. Pi is just a number, pi is 3.14 blah blah blah. So I just want to find out what d is. So both pi and 71 are multiplying the diameter. So to undo multiplying, I'm going to divide both sides by pi times 71. I'm going to divide both sides by pi times 71. Doing that will allow me just to isolate the diameter. So the diameter would be 8352, because by dividing this side here, I'm going to allow myself to cancel these away. So it's going to be 8352 divided by pi times 71. When you're doing this on a calculator, please make sure that your thing in the bottom line goes inside a bracket. And so the diameter will be 8352 divided by pi times 71 inside a bracket, which will be 37.444. And then you would round it to the appropriate number of decimal places. Okay, so this is a more complex question because we are given the arc length, we're told it's 23.2, I have substituted everything into my formula here, and then I've just tried to rearrange my formula. Okay, so the opposite of dividing by 360 is timesing by 360. The opposite of multiplying by 71 in pi is dividing by pi and 71. That will give me a diameter of 37.44.